Hey there, I'm Aaron Gardner. This is student video number 8, I think. So, student video 8. I'm doing problems 1, 2, and 3. Here, I'll show it to you. I'm going to be honest, I was too lazy to write them down, but I figured, hey, I can just put them in the video right here. So, determine if Rolle's theorem applies to the following function on a given interval. If so, find the points that are guaranteed to exist. So, right now we're looking at the interval 0 to 1. So first what we're going to want to do, in my mind at least, is to take x minus 1 squared, and then from there turn it into an extended value just so I can see it and take the derivative a little easier. So you have x minus 1 squared. So you do that, you get, if you expand x minus 1 squared, I'll give you x squared minus 2x plus 1. So if you multiply all that by x, that'll give you x cubed minus 2x squared plus x. Okay, so right there, I see that, and it's a whole lot easier right off the bat for me to be able to take the derivative. So you're going to want to bring the exponent to the front on all these. There's an implied 1 there. So, here, set that up. Okay, so that, and then obviously you subtract 1. So that'll give you 3x squared minus 4x plus 1. Okay, so that right there is our derivative, and then from there we're going to want to use, so we have a simple a, b, and c value. So now we can use the quadratic formula. So that will give us x is equal to negative b, so negative 4, I guess times negative 1 would be 4, so that would be 4 plus or minus the square root of b squared minus 4ac. So that will be 16 minus 4 ac, so that's 3, 1 all over 2a. So if we put all that over 2a, a is equal to 3, so that means all over 6. Okay, this turns into 16 minus 4 times 3 is 12, and then times 1 is obviously still 12, so that turns into 4 plus or minus square root of 16 minus 12, which is 4. 4 plus minus square root of 4 over 6, which then turns into 4 plus or minus 2 over 6. Okay, so with that, your answers are x is equal to 1 and 1/3. So if you're going within the interval that's given, 0 to 1, you're looking for something within that interval. While there is brackets, you can say that it's technically on the end of that, interval. So we see 1/3 right here is the only available option for what x could be equal to, while still providing, while still fitting within that interval. Okay, problem 2. Determine if the mean value theorem applies to the following function on a given interval. If so, find the points that are guaranteed to exist. Okay, so the mean, the mean value theorem is that you want to plug in the values on the endpoints of the interval, so negative 1 and 2 right there. Plug them into the equation, and then you'll want to also use those same values a little bit later. So whenever you plug negative 1 into 7 minus x squared, 7 minus negative 1 squared, so that's equal to 1, so 7 minus 1 is equal to 6. And then for this one, it is 7 minus 2 is the other interval endpoint. 2 squared is equal to 3. So we'll call these f of a and f of b right there. So with f of a and f of b, you are going to see that this stuff right here is equal to, because you have to do f of b minus f of a over b minus a, so that is going to give you 3 minus 6 over 2 plus 1 is equal to minus 3 over 3. So that's great. I had a brain fart when doing it on my lab right there. So you can see that big scribble. At first I thought that was the end, and then I remembered, oh wait, no, that's not the end. So it's not equal to -1 like I thought, but now you have to take the derivative of the original equation, which is 7 minus x squared. So yeah, you're going to get rid of that 7 because there's no x attached. Then bring that exponent to the front, which and subtract 1. So that's going to give you minus 2x, which is the equation. So minus 2x is what we see. F of x. Oop, I need to put an apostrophe there. Okay, you can see that apostrophe. Oh, sorry. I just looked at the camera and realized I was not pointed at it. Is equal to minus 2x. And because we have what the other one is equal to, -1, this equation is equal to that. So minus 2x is equal to minus 1. Okay, so now that we have those, we need to be able to kind of factor it out. So minus 1 over minus 2 is equal to 1/2. And then I'll just write it out and make it simpler. So yeah, that's equal to 1/2. X is equal to 1/2. That is the answer to problem 2. Now for problem 3, it is going to be use L'Hopital's rule to find the following limit. This one's pretty easy. It is pretty much find the derivative of the top and then the derivative of the bottom, and then use the limit to find what that is equal to. So we take it, we're going to move this exponent forward, subtract 1, so on and so forth, with no coefficient of x, and that means that you just get rid of that, same for right there. So that then turns into 4x cubed minus 3x squared minus 2 over 1, because that's what it turns into whenever you just take the derivative of x. It just turns into 1. So then whenever you apply the limit of as x moves towards 1, you're going to replace all of the x's with 1's. So that's 1 cubed minus 1 squared minus 2 over 1. After you do the math, so 1 cubed is the same as 1 squared is 1. So it turns into 4 minus 3 minus 2, which is equal to 4 minus 5, which is just minus 1. So then that turns into minus 1 over 1, giving you an answer of minus 1. Thank you.